Hopefully you don't either. I don't want to rush through this. Okay, I think you're getting the hang. Good, I want you to understand it too. Excellent, I love hearing that. So, oh, you can't see that. Light okay? This okay? Okay, so, when we have a 6% grade, assuming it's 6% the entire way, which we'll deal with when it's not on Monday, most likely. We'll deal with when it's not like that on Monday, most likely. 6% grade implies that for every 6 feet you go up, you go horizontally 100. What if you only go up 3 feet? Then you go, that'd be 3%, not 6%.
Oh.
So if it's 6%, good. Thank you for this. No, this is good. If it's a 6% grade, and you go up 3 feet, how far do you have to go horizontally? Now, for those of you that like equations, and this can be approached equationally, I don't want to force equations on you. Here's Equation Boot Camp, part the first. Okay. 6%, which is 6 over 100. I'm going to go ahead and leave the units off. As long as the units are the same, I don't care what we use. And you've got a whole project, project number 2, devoted to just that idea. How to deal with what's called dimensional analysis. Feet, inches, meters, pounds, square feet, cubic meters, things like that. I don't care what units you use as long as they're the same, 6 over 100. This unit itself doesn't have any kind of a quantity attached to it. So we also agreed that 12 over 200 was equivalent. That's getting hard to see, isn't it? So then my question is, it's always rise over run, right? Whatever the rise is, over whatever the run is. So then I was a bastard, and I said, what if you rose 3 feet, or 3 inches, or 3 somethings, 3 units? I said 3, and then I said, what would the run have to be? Now, there's a whole bunch of different ways to do this. Give me one of them. Give me one of them. Tell me your name again.
Christy.
Christy, go.
So I always learned to do this where you would say 3 over question mark equals 6 over 100.
Hold these together. Like this.
Yep, and then you can multiply the 3 by the 100 and then divide by the 6 like a triangle.
Okay, may I write that out for you? For all of us, actually. So once you get to this point, hopefully, first of all, excuse me, my larynx is detached. Is everybody okay with that? Pretty impressive, huh? That's called 3,000 in the pool this morning and drinking a lot of it doing butterfly. Everybody okay with this equation?
Yeah.
So there's a little bit of equation boot camp. Tiny bit. It won't hurt much. A little bit, just a little bit. So this is what's called a proportion. It's one of my favorite kind of equations because it's useful in so many ways. From shopping, when you're figuring out which is the better deal in a store, to figuring out grades, to figure out all other kind of wonderful mathematics. But once we're here, Christy has what's called the means extremes method. The means, you probably didn't know it was called that. It's pretty classic mathematics. One of these diagonals is called the means, one's called the extremes. I don't know which one is which. But one way of doing this is going 3 times 100 equals 6 times question mark. Is it okay if I use question mark instead of like X? You can use whatever you want. X, Y, smiley face, star. And then, please.
I'm sorry to back us up again.
No, back us up.
Can you tell me again why there's 3? Just one more.
Oh, it's a number I made up. I said, what if we only rose 3 feet?
Okay.
My question was, if we do that, what's that? Sorry. Yeah, that's a great backup, actually, because chances are somebody else is wondering, where the hell did 3 come from? Came out of here. I just popped out. Let's do 3. Fair?
Fair.
Okay, good. Fair, hopefully. I always ask fair. I don't say good, because it's math. No, it's not good, it's math. It's fair. It's believable, hopefully, swallowable, digestible. From here, it's a linear equation. You've got a variable to the first power. Then it's just a matter of solving it. Christy, continue.
So basic. Well, when you put it like that way, it confuses me.
I'm sorry.
But
Do you want an X?
I kind of just make a triangle on the 6 over 100 equals 3 over question mark, and I make a triangle leaving the question mark out.
So you do this times this divided by this.
Yes.
Oh, which is what I was going to do next. This times this is 300 divided by that.
Yes.
300 divided by 6 equals 50. No, I like your method. Your method's slick. I like that. So that's a simplified means extremes. Once you've got the variable in this place, That times that over the last piece. So it's the two numbers in the diagonal that you know, divided by the one that you don't. Assuming you've got a basic proportion, that's beautiful. That's awesome. Got no problem with that whatsoever, work every time. As long as you've got a pure proportion, which we're mostly going to have in this class. Actually, we're always going to have in this class. Anybody do it differently? Please, Michael.
Yes.
Michael, go, my friend.
Just divide the 6 by 2 to get it to a 3, and then divide the 100 by the same 2, which gives you 50.
Another way of looking at it is saying, well, how did we get from 6 to 3? Multiplicatively, because this is division, so it's the opposite of multiplication. We went from here to here. Use a better color. Gesundheit. I had a green marker somewhere. Oh, there it is. 6 to 3, we divided by 2. We'd also have to do that to get from here to here. So 100 divided by 2 gives you 50 as well. Works beautifully. Both have a... They have a third way? There might even be a third way of doing it. I alternate between my more convoluted version of Christie's and Michael's. It depends on the kind of number. Both have pros and cons. The pro of Michael's way is it's very quick. The con of Michael's way is, suppose the 3 were, instead of being a 3, a 4. It's not easy to do, what do you divide 6 by to get to 4? You can do it, you can totally do it, but it's not as quick as divided by 2. That's a pro of Christie's way, which is, oh, it doesn't matter what you're multiplying by because you're going to avoid that by avoiding this little middle. So your choice, I don't care which way you do it, as long as you're comfortable doing one of those, or some third or fourth or fifth way, doesn't matter to me. But that's a proportion, solving a proportion. If you know any 3 of the pieces of the proportion, you'll know the 4th. Michelle, go ahead, ask me that question. You just moved, didn't you? I'm like an amphibian. I see motion, I'm like, ah! So, it's false positives. Sean, false positive rule. Constantly assuming everybody's got a question and is kind of afraid to ask, so I jump. So, and therefore scare people out of the room. So, as long as you have 3 of the numbers, you can find the 4th. The good news about grade problems, you're always going to have 2 of them. Because you're going to know the grade. And that's 2 of them. Something over 100. So you're going to have this fraction, whatever the grade is. And you're going to have to know one of these to know the other. Believable? The good news, too, is that both Christie and Michael's methods are going to work if you know the denominator and need the numerator. Let's make up one. Let's make up one. Somebody give me a run. So we know the grade 6 over 100, yes? Make up a run for us to play with.
25.2.
25.2! Yes! Ugly.